Two cyclists, A and B, are going on a bike ride and are meeting at an orchard. They left home at the same time. Functions A and B give their distance from the orchard in miles after riding for X hours. The functions are defined by these equations. A of x equals 48.5 minus 21x, and b of x equals 42 minus 16.8x. For each question, explain or show your reasoning. Number 1. Which cyclist lives farther away from the orchard? These functions are written in slope-intercept form. And since the function gives their distance from the orchard, the y-intercept will tell us how far away they are from the orchard when they start from their homes. So if we look at A, the intercept is 48.5. So A lives 48.5 miles away. For B, that y-intercept is 42. So B lives 42 miles away. That means A lives farther away. Number 2, who will get to the orchard first? How much earlier will that cyclist arrive? The function is measuring how far away they are from the orchard. So when they get to the orchard, the function will equal 0. So first, we set A equal to 0. So 0 equals 4.85 minus 21x. I'm going to add 21x to both sides. So I get 21x equals 48.5. And now I'm going to divide both sides by 21. So I end up with x equals 48.5 divided by 21 equals 2.3. And this is measuring hours. So it will take cyclist A 2.3 hours to get to the orchard. Now we're going to look at B and do the same thing. Set it equal to 0. First, we're going to add 16.8x to both sides. Then we're going to divide both sides by 16.8. And we find out that x equals 42 divided by 16.8, which equals approximately 2.5. Again, this is hours. So if I want to know who will get to the orchard first, cyclist A will get there in 2.3 hours, cyclist B will take 2.5 hours. So cyclist A gets there first. And how much earlier? We're going to take 2.5 minus 2.3, and that's 0.2. So cyclist A by 0.2 hours. Number 3. Is there a time when both cyclists are the same distance from the orchard? To find this out, we set the two functions equal to each other. So we have 48.5 minus 21x equals 42 minus 16.8x. I want positive x, so I'm going to add 21x to both sides. That gives me 48.5 equals 42. And if I add 16.8 negative plus 21, I get 4.2x. So that's plus 4.2x. Now I'm going to subtract 42 from each side. So 48.5 minus 42 is 6.5. And that equals 4.2x. And finally, to get x by itself, I'm going to divide both sides by 4.2. So 6.5 divided by 4.2 equals approximately 1.5. And x measures hours. Now, if I want to know how far they are from the orchard, I can substitute 1.5 into either of the original equations to see where that cyclist is. And because they are the same at that distance, we'll have the distance for both. So I will choose A of x, and I will say 48.5 minus 21 times 1.5. First, we multiply. Negative 21 times 1.5 equals negative 31.5. And 48.5 minus 31.5 equals 17. So after 1.5 hours, both will be 17 miles from the orchard. This is the point at which they will catch up with each other, and then cyclist A will pass cyclist B. Each equation defines a function. Write an equation for the inverse function. So number 1, y of x equals 65 plus 5x. So I'm going to subtract 65 from each side. Now I have y of x minus 65 equals 5x. Or we can just write y. Now I need to divide both sides by 5. So now x equals y minus 65 divided by 5. Now, instead of having a function that solves for y using x as the input, I now have the inverse function which solves for x by using y as the input. Number 2, f of t equals 3.5 minus 0.5t. So the first thing I'll do is subtract 3.5 from both sides. And now I have f minus 3.5 equals negative 0.5t. To get t by itself, I'm going to divide both sides by negative 0.5. And my inverse function is t equals f minus 3.5 divided by negative 0.5. So now t is the inverse function of f. And number 3, p of n equals n divided by 3 minus 1.2. So the first thing we'll do is add 1.2 to both sides. Now I have p plus 1.2 equals n divided by 3. Now to get n by itself, we will multiply both sides by 3. And now we have the inverse function n equals 3p plus 3.6. So an inverse function solves for the opposite variable. A college student borrows $360 from his cousin to repair his car. He agrees to pay $15 per week until the loan is paid off. Function L represents the amount owed W weeks after the student borrows the money. Write an equation to represent this function. Use function notation. When we write in function notation, we start with the function name. In this example, that's capital L. Then we have our input in parentheses. In this example, that is W. And it equals, in this case, it's going to be $15 per week. And that is going to be subtracted from the total, which is $360. So we can write 360 minus 15W. So the 360 is the original amount borrowed. We're taking the number of weeks after the money was borrowed. We're multiplying that by $15 per week. And we're subtracting that amount that has been repaid from the amount that was owed. And that will tell us how much money is currently owed. Number 2, write an equation to represent the inverse of function L. Explain what information it tells us about the situation. So the first thing we're going to do is subtract 360 from each side. So now we have L minus 360 equals negative 15W. Then to get W by itself, we are going to divide both sides by negative 15. And we have W equals L minus 360 divided by negative 15. This is the inverse function, and this tells us how many weeks since the loan using the amount owed. As input. Number 3, how many weeks will it take the student to pay off the loan? So if I want to know how many weeks, I'm going to use the inverse function. And if the loan is paid off, then the loan amount owed would be 0. So we're going to substitute 0 in for L. 0 minus 360 is negative 360. Negative 360 divided by negative 15 equals 24, and W represents weeks. So it's 24 weeks to pay off the loan. So this is how you turn a word problem into a function. Then write the inverse function. Then use the inverse function to solve the word problem. A family bought a used car that had been driven 12,000 miles. The table shows the total distance in miles that the car has traveled each year since the purchase. On average, how many miles does the family drive each year? Explain or show your reasoning. So, if we want the average number of miles, we're looking for the slope. So, we end with 21,750 miles total. And we started with 12,000 miles. We end 3 years after purchase, and we started 0 years. So 21,750 minus 12,000 would be 9,750 miles driven in 3 years. And 9,750 divided by 3 would be 3,250 miles per year. Number 2, write an equation that could define function m, which gives the total miles traveled t years since the purchase. Use function notation. So when we use function notation, we start with the name, which is capital M. We have our input in parentheses, which is t. And we can write this in slope-intercept form. We just found our slope, which is 3,250 miles per year times t, the number of years. And the y-intercept would be the total miles at time of purchase, which is 12,000. So this would be the function notation. Number 3, write an equation that is the inverse of function m. Explain what information it tells us about the situation. So the first thing we would do is subtract 12,000 from each side. So we would have m of t, or let's just call it m, minus 12,000 equals 3,250 t. Now we need to divide both sides by 3,250, and that gives us the inverse function t equals m minus 12,000 divided by 3,250. And this tells us how many years since purchase using total miles as input. Number 4, if the family's driving trend continues, when will the car have traveled 50,000 miles? So if they are giving us total miles, which is capital M, and they want us to find the time, which is t, we're going to use the inverse function. So t equals 50,000 minus 12,000 divided by 3,250. 50,000 minus 12,000 is 38,000. And 38,000 divided by 3,250 equals 11.7. And time represents years after purchase. So this is how you use a word problem and a table to find the slope, then use the slope and the intercept to write the function notation, then use that function notation to write the inverse function, then use that inverse function to solve a word problem. The number of chirps that crickets make is closely related to the temperature of their environment. When the temperature is between 12 and 38 degrees Celsius, we can tell the temperature by counting the number of chirps. A formula that is commonly used to find the temperature in degrees Celsius is count the number of chirps in 25 seconds, divide by 3, then add 4 to get the temperature. Let M be the number of chirps that crickets make in 25 seconds, and C be the temperature in degrees Celsius. What is the temperature when 84 chirps are heard in 25 seconds? So we know we want to find the temperature. That would be C. That equals the number of chirps, which they told us was 84. Divide that by 3. So 84 divided by 3. Then add 4. So plus 4. So now 84 divided by 3 equals 28. And 28 plus 4 equals 32. And this 32 references C, which is 32 degrees Celsius. Write an equation that defines C as a function of M. So we have a function that is C equals M, the number of chirps in 25 seconds, divided by 3 plus 4. Number 3. How many chirps would we expect to hear in 25 seconds when it's 14 degrees Celsius. So now we're going to plug in 14 for C equals M divided by 3 plus 4. Next, I would subtract 4 from both sides. So I have 14 minus 4 is 10. 10 equals M divided by 3. Now I multiply both sides by 3. 10 times 3 is 30 equals M. So that is 30 chirps in 25 seconds. Write an equation that defines the inverse of the function you wrote. Explain what the inverse function tells us about the situation. We take the original equation, C equals M divided by 3 plus 4. We subtract 4 from both sides. That becomes C minus 4 equals M divided by 3. Then we multiply everything by 3, and we get 3C minus 12 equals M. And this tells us how many chirps in 25 seconds using degrees Celsius as the input. Page 3. The parking rate R for a car in a garage is a function of T, the hours it is parked. Number 1, find R of 1. In this case, 1 is 1 hour. So when we look at the table, this function would match the first time because 1 hour is between 0 and 2 hours. So my output is that this is free. So R of 1 equals free. Number 2, find R of 4.5. Well, 4.5 is 4.5 hours, and that would fall between 4 and 5 hours, and the output is a $6 cost. So R of 4.5 equals $6. And number 3, find R of 8. 8 is 8 hours. That would fall under the category of greater than 7 hours. And the output is $8. So R of 8 equals $8. Describe the domain and range of the function this graph represents. So our domain represents the x values. So this is all numbers, since we have a solid line, between, this starts at -5 and ends at 10, except the 2 points where we have hollow points. And that happens at -3 and again at 6. So the domain is all numbers between -5 and 10, except -3 and 6. The range represents the y values. So this represents all numbers, because we have the solid line, between, it starts down here at -2 and it ends up at 4. And there's no exceptions to this, because even though there are hollow points, it does still equal -2 at this solid point and the line going over to that hollow point. And it still does equal 4 at the solid point and the line leading over to the hollow point. So this would be your domain and range. The graph shows the attendance at a sports game as a function of time in minutes. Number 1, describe how attendance changed over time. So we can see that attendance grew quickly for the first 10 minutes. Then we see that it slowed down for 5 minutes. Then we see that it stayed the same from 15 minutes to 45 minutes, so that's 30 minutes total. Then we see that it lost attendance or declined quickly for 5 minutes. Stayed the same for 5 minutes. then declined quickly for 15 minutes. Number 2, describe the domain. The domain represents all the input numbers or all the x values. So the domain is all numbers between 0 and 70. Number 3, describe the range. The range represents all the possible outputs or y values. So in this example, range is all numbers between 0 and looks to be about 55.
Two children set up a lemonade stand in their front yard. They charge $1 for every cup. They sell a total of 15 cups of lemonade. The amount of money the children earned, R dollars, is a function of the number of cups of lemonade they sold, N. Number 1. Is 20 part of the domain of this function? Explain your reasoning. So number 1 is referencing the domain. The domain is our input. Anytime you see is a function of, the next thing is your input. So my input is the number of cups of lemonade they sold. They sold a total of 15 cups, so 20 is not part of the domain. No, because the domain is 0 to 15. Number 2, what does the range of this function represent? Well, the range is the output. And if the number of cups of lemonade they sold is the input, that means the amount of money is my output. So the range represents the money the children earned. Describe the set of values in the range of R. Well, if they charge $1 for every cup and they sell a total of 15 cups, the range is all whole numbers between 0 and 15. And we should go back and add in to number 1 that the domain is also whole numbers. Because we cannot sell partial cups of lemonade. And number 4, is the graph of this function discrete or continuous? Well, first we can think about our input. The input is the number of cups sold. We cannot sell partial cups. Then we think about the output. The output is $1 per cup. So the range also needed to be whole numbers. Since these cannot be partial numbers, the graph is discrete because we need whole numbers for input and output. Elena plays the piano for 30 minutes each practice day. The total number of minutes that Elena practiced last week is a function of n, the number of practice days. Find the domain and range for this function. So, the domain is my input, and my input is n, the number of practice days. So my domain would need to be whole numbers because I cannot have partial practice days. She either practices or she doesn't practice. And they would need to be positive numbers because she cannot practice negative days. So the domain is all positive whole numbers. The range is talking about the output. And the output is the total number of minutes, P, that Elena practiced last week. So now we know that this is only talking about 1 week. So the domain is all positive whole numbers between 0 and 7, since it's limited to 1 week. The range is multiples of 30 between 0 and 210. Because she is playing piano for 30 minutes each day she practices, so the least amount of time that she can practice is 0 if she practices no days, and the most she can practice is 210 minutes if she practices all 7 days, and we must have multiples of 30 because it says that she plays 30 minutes each practice day. So we could not have any numbers in between those multiples of 30. And our last practice problem, here is the graph of function f, which represents Andre's distance from his bicycle as he walked in the park. Number 1, estimate f of 5. The number in parentheses is our input. So we go over to x equals 5. We go up until we hit the line, and then we look left for the value of y, and it appears that f of 5 equals 5 because that's the y value when we get to that point on the graph. Number 2, estimate f of 17. Again, the number in parentheses is the input, so we go over until x equals 17. We go up until we hit the graph, and then we go left to find the y value, and the y value is 1. So it appears that f of 17 equals 1. Number 3, for what value of t does f of t equal 8? The number that the function equals is the y value. So we go up to y equals 8, and we come across. And it appears that happens when t equals 9. But if we keep going, it also looks like this happens when t equals 20. And if we continue going, it looks like it happens again when t equals 22. Number 4, for what values of t does f of t equal 6.5? Again, the number the function equals is the y value. So if we go to 6.5 and we go across, it looks like this happens when t equals 6. If we continue going, it looks like this happens from t equals 11 until t equals 14.5. If we keep going, it looks like this happens again when t equals 19.5. And if we keep going, it looks like it happens again at about t equals 23.5. And finally, for what values of t does f of t equal 10? Again, the number the function equals is the y value. So we go up to y equals 10. We look across, and we never hit the graph. So there are no values of t where f of t equals 10. If you have any questions over anything we've covered in this second half of Unit 4, please use class time to get clarification before the test on Monday. This includes domain and range. This includes absolute value functions. This includes piecewise functions. And this includes inverse functions.